Okay, well, this is your very first video. I'm not sure how many it's going to take to get through this whole review. So I'm just going to start, and then as time runs out, I'll start a new video, and we'll see how long it takes. So going way back to the very beginning, when we were talking about all these vocabulary words regarding just geometry in general, we have 3 collinear points. Co means like with or together, and then it has the word line, and so collinear is in the same line. So I need 3 points that are all in the same line. So for example, C, X, and D. Another example would be E, Y, and G. Those are all in the same line. 3 non-collinear points would be 3 that are not in the same line. So any 2 points will make a line. So pick any 2 points, like F and H. They are in the same line because any 2 points are. So I just need something that's not, like C, X, B, anything else that is not in the same line. For coplanar, co is with, plane is in the same plane. So this would be, if I'm looking at this cube, anything that's on the same face of a cube. So A, C, X, B, those are all points that are on the top of the cube, so they'd be in the same plane. For non-coplanar points, so now I need 4 points that are not on the same plane, or 4 points that are not on the same face. So A, C, F, and E is an example. There's many examples that you could use. So if you're not sure if your example works, then just come ask me and let me know. Remember that any 2 points make a line, and any 3 points make a plane. What else do you need to know about this? Let's see, lines intersect in a point. And planes intersect in a line. So if I'm looking at line BD and line CD, they intersect at point D. But if I'm looking at the whole top of the box and the whole front of the box, they intersect at line CD. Okay, so that's a difference there. Moving on to number 2, vertical angles. I think you guys remember that one a lot because we've used it a lot since then. So vertical angles, those are across from each other, and they have to be made with the same lines. So what I mean by that is this little angle, CAD, and this big angle, FAE, those are across from each other, but they're not made from the same lines. So remember that vertical angles are congruent to each other, so that might help. So an example of vertical angles would be angle FAB and angle DAE. So that's this part, and then across this part. So those 2 are vertical angles. Vertical angles are, nope, I'm just kidding. Okay, complementary. Complementary have to equal to 90 degrees. They do not have to be next to each other to equal 90 degrees, but it's just 2 angles that equal 90 degrees. Because this is a right angle, and these 2 lines are intersecting, that would mean this is a right angle, this is a right angle, and then these 2 together would also have to be a right angle. So angle BAC and angle CAD are your complementary angles, but they don't have to be next to each other. It's just in this picture, that's our only example. Our supplementary angles have to equal 180 degrees. So we could use angle FAE and angle EAD. So that's this angle, which is 90, and this angle, which is 90. But you could use our vertical angles as our example of supplementary, because if they're both 90, then together they equal 180. Adjacent angles are next to each other, and so they share a ray or a side of their angle. So any two angles that are next to each other. So our example of complementary angles, those were adjacent. Our example of supplementary angles were adjacent. Our vertical angles were not adjacent. So I'm going to use angle CAD, this little angle, and angle DAE, this right angle next to it. So I used those two for my example of adjacent angles. Number 3, can the statement be assumed to be given in the figure below, yes or no? So remember things that we can assume. I know when you start looking at pictures, you like to just say that things are what they are, but don't assume things. FG and GJ are congruent. We cannot assume congruency. So that's a no. Angle EGL, this little angle, and KGM, this angle, those are vertical angles, and we can assume that those are vertical angles because we can assume the straightness of lines. So I can assume that this line and this line are straight. So because those are straight lines, these are vertical angles, so they are congruent. LGJ, GJ is a right angle. It might look like it, but we can't assume. We can't assume the sizes. FE and KL are parallel. That would be a no. We don't have the arrows. So remember, parallel lines, they would have these little arrows on them. And we don't have those. And then FEG, and LGE are congruent. That would be a no. We cannot assume that congruent relationship. Those are alternate interior angles, but they're only congruent with parallel lines. So if D had been true, then E would be true, because those are alternate interior angles. Any two lines cut by a transversal has these relationships, but only when they are parallel do those relationships mean anything in terms of congruency. All right. Moving on to some of our logic information. If a polygon has 3 sides, then it is a triangle. So this is our conditional. It's what we start with. Inside of our conditional, we have a hypothesis. That's this part. It's kind of what comes first. It's what comes after the if part. So if a polygon has 3 sides, then it is a triangle. That would be our conclusion. So we're saying if a triangle, or if a polygon has 3 sides, then it is a triangle. For the converse, we switch the H and the C. So we switch our hypothesis and conclusion. So if a polygon is a triangle, then it has 3 sides. The inverse is our opposite day. So anything, we just kind of add the not if there's not a not. If there is a not, we take out the not. So it's just the opposite of whatever it says. So if a polygon does not have 3 sides, then it is not a triangle. The contrapositive is when we do both. You do the switch and opposite day. We do a switch and opposite day. So we're gonna switch just like for the converse and then add the not like we did for the inverse. So if a polygon is not a triangle, then it does not have 3 sides. Okay, then for the biconditional, is the following a biconditional? The biconditional means that your conditional and converse have the same truth value. So our conditional, way up here, this is true. If a polygon has 3 sides, it is a triangle. The converse, if a polygon is a triangle, then it has 3 sides. That's also true. So conditional and converse have same truth value. So in this case, yes, it is. So a biconditional would be written as if and only if a polygon has 3 sides, then it is a triangle, which means only 3-sided shapes are called triangles and only triangles have 3 sides. So that's kind of like the thing that it goes both ways. I will tell you that on your exam, it's going to give you a sentence and then it's going to give you one of these already written, and you just have to identify which one it is. So you just need to know, and it's not the biconditional, so you just need to know what the converse, inverse, and contrapositive would do to this statement. Okay, that's what it's going to look like on your exam. So I'm going to stop right here for this video. Yeah, I'm going to stop right here for this video, and your next one will continue.